Pull that bottle out of your pantry. Sunflower oil. You see it every time you cook, right? It's just oil. Looks simple. Pour it, heat it, done. But what if I told you that this everyday kitchen staple starts as tiny black seeds and goes through a massive, mind-blowing industrial journey? We're talking about a process of incredible scale, precision engineering, and turning millions of tons of seeds into that clear liquid. Forget your garden patch. Get ready to see the hidden factory secrets behind pure cooking oil. It all begins in the sun-drenched giants of the plant world. Sunflowers. Picture fields that stretch beyond the horizon. Golden faces tracking the sun. These aren't grown just for beauty. They're an industrial crop, covering massive hectares in places like the American Midwest, Eastern Europe, and South America. Contract farmers cultivate them specifically for oil content. When the heavy heads hang low, packed with seeds, specialized harvesters sweep through. These machines are beasts. They rip off the heads, shaking and collecting tons upon tons of seeds in hours. Enough seeds from just one field could fill dozens of semi-trucks. It's harvesting on an epic scale. Once those trucks dump their colossal loads at the processing plant, the real industrial ballet begins. First challenge, cleaning. Seeds from the field come with all sorts of hitchhikers. Dirt, stones, stems, leaves, even metal bits. Contaminants can damage machinery and ruin entire batches of oil. So, the seeds hit a high-speed cleaning gauntlet. They pass over vibrating screens that filter debris, under powerful magnets that yank out metal, and through air classifiers that blow away lighter impurities. The most impressive tech? Optical sorters. Cameras scan every single seed flying by on a conveyor, using light and imaging to spot defects or foreign objects. Precise air jets blast away anything that doesn't belong. They clean millions of seeds per hour, ensuring only pure seeds move forward. This is factory efficiency in action. Clean seeds still have their shells, and the oil is hidden inside the kernel. Next up, hulling. Machines use impact or friction, think high-speed centrifuges or rollers, to crack the tough outer hulls without smashing the valuable kernels inside. It's a delicate balance of force and precision. Then, incredibly clever systems use gravity and air currents to separate the lightweight hulls from the heavier kernels. The hulls aren't wasted. They're often used as fuel for the plant's boilers or processed into animal feed. Maximizing yield means using every part of the seed. Now for the main event, getting that oil out. There are usually two methods. First, mechanical pressing. The kernels are fed into massive screw presses. These are industrial powerhouses. They twist and compress the seeds with enormous force. We're talking pressure equivalent to stacking several elephants on a single spot. Under this immense pressure, the crude oil is literally squeezed out. It flows out in a thick, brownish-yellow stream. This first press extracts a significant portion of the oil, leaving behind a compressed cake of seed material. To extract the maximum amount of oil, especially from the leftover seed cake, a second method is common: solvent extraction. Yes, solvent might sound chemical, but it's a food-grade process, and the solvent is completely removed later. The compressed cake is washed with a specific solvent, like hexane, which dissolves fats. Think of it like a supermagnet pulling out the oil remaining in the material. The mixture of oil and solvent is then heated. The solvent evaporates quickly and is captured for reuse, leaving behind the crude oil. This process gets virtually every drop of oil possible, maximizing efficiency on an industrial scale. After pressing and extraction, you have crude sunflower oil. But it's not the clear, neutral oil you pour in your pan. It's cloudy, has a strong odor, and might contain trace impurities. So, it undergoes refining, a multi-step purification ballet. Degumming removes sticky phosphorus compounds. Bleaching uses natural clays to absorb pigments and make the oil lighter. Then comes deodorization, perhaps the most critical step for a cooking oil. Steam is passed through the hot oil under vacuum, stripping away compounds that cause smells and unwanted flavors. This is what gives the oil its pure, neutral taste and makes it stable, so it doesn't go rancid quickly. The final steps ensure maximum purity and quality. The refined oil goes through polishing filters to remove any last tiny particles, making it perfectly clear. Then, rigorous quality control takes over. Labs at the factory test every single batch. They check for clarity, color, free fatty acids, peroxide value to measure oxidation, and overall stability. This isn't a quick check. It's precise chemical analysis, ensuring the oil meets strict global standards for food safety and quality. Only batches that pass this final gauntlet are approved for packaging. Packaging is the high-speed finale. The pure, refined oil flows to the bottling lines. Empty plastic bottles or glass jars zip along conveyors at incredible speed. They're rapidly filled with precise amounts of oil, capped, sealed, and labeled by automated machines in a blur of motion. A large plant can bottle tens of thousands of units per hour. These finished bottles are automatically packed into boxes, stacked onto pallets by robotic arms, and readied for distribution. From a vast field of seeds to perfectly sealed bottles, it's a journey of transformation, driven by engineering and scale. So, the next time you pour that clear, pure sunflower oil, take a moment to think about the complex industrial magic that happened behind the scenes. From countless tiny seeds, through powerful presses, intricate cleaning systems, chemical purification, and high-speed bottling lines, it's a product of massive scale, precision, and technology. It's a fascinating look at how agriculture meets industrial engineering to create something essential for everyday life. What part of this incredible process surprised you the most? Let us know in the comments. Hey, pull up a chair. You know that Starbucks cup? The one you see everywhere, the taste you can spot across a crowded room? Looks pretty straightforward, right? Just a little coffee, maybe some milk. But what if I told you that behind that simple cup is a global operation so vast, so precise, it's mind-blowing? We're talking about a supply chain that spans continents, a process built on incredible technology, and enough coffee moving every single day to fill. Well, let's just say it's a lot. Forget everything you thought you knew about coffee. Get ready to dive deep into the hidden industrial secrets of how Starbucks brings that coffee from a distant farm to your hands. The journey starts thousands of miles away, in places you might only dream of. The lush, vital coffee belt near the equator. Latin America, Africa, Asia. This isn't farming on a small scale. Starbucks works with millions of coffee farmers, building relationships that stretch back decades. They source massive amounts of green, unroasted coffee beans, demanding specific quality and flavor profiles unique to each region. Picture vast landscapes covered in coffee plants, where harvest isn't just picking fruit. It's a critical first step in a global race against time and quality loss. The beans are processed right there at the origin to remove the fruit and dry them, then packed into huge bags, hundreds of pounds each, ready for their epic voyage across oceans. One single bean in your cup could have traveled over 5,000 miles before it even hits the roaster. When these colossal shipments of green beans finally reach one of Starbucks' massive roasting plants, facilities the size of multiple football fields in places like Kent, Washington, or South Carolina, they face their first great challenge: cleaning. You wouldn't believe what can sneak into a shipment from remote farms. Twigs, stones, metal fragments, even lost tools. A single foreign object can ruin an entire batch, costing thousands. So, the beans are subjected to an intense cleaning gauntlet. Giant magnets yank out metal, screens sift out debris, and air currents separate lighter impurities. The most astonishing part? Advanced optical sorters. Cameras analyze every single bean as it flies past on a high-speed conveyor, using light and imaging to spot defects, discoloration, anything that isn't a perfect green bean. Rejected beans are blasted away by precise jets of air. They process literally millions of beans per hour, ensuring only the flawless make the cut. It's like a high-tech security checkpoint for coffee. Now, the transformation, roasting. This is where those hard, green seeds undergo a chemical metamorphosis. Starbucks uses custom-built industrial roasters, monstrous rotating drums heated to blistering temperatures, often exceeding 500 degrees Fahrenheit. Inside, the beans tumble and dance in the intense heat. This isn't just burning them, it's a complex culinary science. The Maillard reaction and caramelization working in overdrive. Sugars unlock, acids develop, and hundreds of volatile aromatic compounds are created in seconds. It's a symphony of heat and chemistry. Precision is everything. Even a few seconds too long, or a few degrees off can shift the flavor profile entirely, turning a bright, complex coffee into something flat or bitter. Starbucks is famous for its signature roasts, from the light blonde to the intense dark. Achieving that consistent taste, bottle after bottle, region after region, across millions of pounds, is an engineering marvel controlled by sophisticated computer systems. But it's not just machines. Master roasters, artisans with years of training, monitor the process, listening for the distinct first crack and second crack sounds the beans make as they expand and release gases. They use their senses, smell, sight, even sound, coupled with data to fine-tune the roast. It's where human expertise meets industrial scale, ensuring the Pike Place roast you love tastes exactly the same in Seattle as it does in Shanghai, batch after batch. That level of consistent quality on this scale is almost unbelievable. Immediately after hitting that perfect roast point, the beans are practically glowing with heat. They have to be cooled instantly to stop the chemical reactions. Massive cooling trays with powerful fans suck air rapidly through the hot beans, bringing their temperature down in seconds. This quick cool down is vital. Slow cooling can damage the flavor. Then comes degassing. Freshly roasted beans naturally release carbon dioxide. It's a sign of freshness, but if trapped, it'll burst the packaging. Large facilities manage this with precision, sometimes resting beans in silos, or using specialized systems to control the gas release before packaging. It's all about preserving that peak flavor. Packaging is a high-speed ballet of engineering designed for one purpose: locking in freshness against coffee's worst enemies: light, moisture, and oxygen. Starbucks coffee bags are built from multi-layer, high-barrier materials that create an impenetrable shield. And look closely at the front of the bag. See that tiny plastic button? That's a one-way valve, a stroke of genius in packaging. It allows the CO2 gas naturally degassing from the fresh beans inside the bag to escape, preventing it from popping. But crucial for freshness, it absolutely prevents oxygen from getting in. High-speed automated lines weigh, fill, seal, and valve millions of bags per day with incredible speed and accuracy. The final guardian of quality? Starbucks' sensory labs. Located at roasting plants and headquarters, these labs are staffed by certified coffee cuppers. These aren't just people who like coffee, they're highly trained experts who can detect hundreds of flavor notes and defects. Every single roast batch is sampled. Cuppers evaluate aroma, acidity, body, and flavor, comparing it against strict global standards. It's a rigorous, meticulous process. Like a tasting Olympics for coffee, ensuring that what ends up in your cup meets the exact profile Starbucks promises. This marriage of human sensory skill and industrial consistency is the final secret ingredient. So, the next time you take a sip of your favorite Starbucks coffee, remember the incredible hidden journey it took. From a tiny seed grown thousands of miles away, nurtured by farmers, transported across oceans, cleaned by optical scanners, transformed in roaring hot roasters, perfected by master artisans and computers, and sealed with precision in high-tech bags. It's more than just coffee. It's a product of a vast global network, incredible engineering, and a relentless focus on quality. It's a fascinating look at how something so simple in your hand is the result of massive industrial secrets. What part of this immense process surprised you the most? Let us know in the comments. One factory, 1 million chickens, over 500,000 eggs every single day, and roughly 120 tons of feed. Imagine that. Automated systems handle feeding, sorting, and packaging to keep this process running non-stop. Every day, these chickens drink enough water to fill 29 Olympic-sized swimming pools. Modern tech makes it possible for a chicken metropolis to run with just about 100 workers. How is that even possible? You'll find out in our video. Chickens on large farms are kept either in cages or in free-range systems. If they're in cages, these are arranged in multi-level rows. Think of it like a chicken skyscraper. Each cage has everything a chicken needs: perches, feeders, drinkers, and even a sloped floor so eggs roll straight into a collection tray after being laid. On the other hand, free-range chickens have more space to roam. They get access to the outdoors, though it's usually not a lush green field, but specially designed enclosed areas. Even in these systems, everything is organized down to the smallest detail. This factory houses 1 million chickens in a caged system, covering over 25 acres. By comparison, the same number of birds in a free-range system would need more than 80 acres. Here's another fascinating fact. Modern farms maximize vertical space, especially in caged systems, to optimize efficiency. Most of the area is used for multi-level production facilities, housing cages, feed silos, sorting rooms, and staff areas. The chickens are fed specially formulated feed to ensure consistent egg production. This feed is a mix of grains, corn, soybeans, and added vitamins and minerals. And here's the kicker. Every single gram of feed is crucial because it determines the quality and quantity of the eggs. Feed is constantly tested for protein, calcium, and potential contaminants. Some farms even add herbal extracts to keep the chickens healthy without antibiotics. Large farms use automated feeding systems. Feed is distributed through pipes or conveyor belts, filling feeders in the cages or barns. Sensors monitor feed levels and automatically dispense more when needed. Chickens receive feed tailored to their stage of life. Young chicks get starter feed rich in protein and energy. Layers receive feed high in calcium, vitamins, and trace minerals for strong eggshells. Chickens nearing the end of their life cycle get finisher feed. The feed also includes additives to support digestive health, boost immunity, and improve egg quality. Chickens are fed 2 to 4 times daily, depending on the system. Some farms schedule feedings right before laying time to encourage consistent egg production. Layers consume about 5 ounces of feed daily. For 1 million chickens, that's nearly 120 tons of feed every day, or about 40,000 tons annually. Just look at the massive silos and transportation systems needed to manage that volume. In addition to feed, chickens are provided with clean drinking water. Nipple drinkers allow them to drink without spilling. 1 million chickens require over 2.5 million gallons of water annually, roughly the amount held by 29 Olympic-sized swimming pools. Feed is stored in silos, protected from moisture and mold. Its nutritional content is constantly analyzed to ensure quality. Modern farms even use software to track how much feed each group of chickens consumes. In some free-range systems, chickens are also allowed to forage for grass, insects, and grains, making their diet more natural. But even here, the primary feed is delivered automatically. Feeding systems are key to ensuring chickens lay eggs consistently and stay healthy throughout their production cycle. After laying, eggs roll into trays through special chutes. From there, they're transported on conveyor belts. Imagine an endless line of eggs floating towards sorting machines. These machines check for defects, discarding damaged or undersized eggs using special scanners that literally illuminate the eggs. It's futuristic. Before packaging, eggs are carefully washed in warm water with gentle disinfectants. This step ensures their safety. And no, it's not just a quick rinse. Eggs go through several warm water baths to remove dirt and microorganisms. Then they're dried and coated with a thin layer of food-grade wax for protection. At the sorting stage, each egg is weighed and categorized: large, medium, and so on. Depending on the category, eggs are packed into boxes. Simultaneously, shells are dried to prevent moisture that could lead to bacterial growth. Clean inspected eggs are placed in cartons or plastic trays by automated arms. Packaging includes details like packing date, grade, size, and producer certification. Storing such a daily volume of eggs requires refrigerators with over 70,000 cubic feet of capacity, about 40 large refrigerated trucks. After packaging, eggs are sent to storage facilities or logistics centers. Here, strict temperature controls between 32 and 40 degrees Fahrenheit keep them fresh. Eggs are transported in refrigerated trucks to prevent spoilage. At distribution centers, eggs are sorted based on supermarket orders and quickly delivered to stores or markets. Modern logistics systems reduce the time from farm to shelf to just a few days. Once on supermarket shelves, eggs are stored in refrigerators to maintain freshness. Consistent storage temperatures are crucial because sudden changes can cause condensation, increasing the risk of shell contamination. Consumers choose eggs based on size, price, brand, or labels like organic or free range. At home, eggs are stored in the fridge. Freshness is easy to check. If an egg sinks in water, it's good to use. Although large-scale farms are resource-intensive, many are adopting eco-friendly initiatives. These efforts not only reduce environmental impact, but also meet growing consumer demand for sustainable products. Some farms invest in solar panels on facility roofs or nearby solar fields, covering 30 to 50% of their energy needs. Chicken manure, a natural byproduct of any farm, is a valuable resource for agriculture. Chickens produce as much manure as the feed they consume, over 100 tons daily. Manure is collected, dried, and processed into organic fertilizer. Instead of creating waste, farms provide a product that restores soil fertility and reduces reliance on chemical fertilizers. Fertilizer production from chicken manure also lowers methane emissions compared to natural decomposition. Did you know a single chicken lays 1 egg a day? Of course, 1 million chickens don't equal 1 million eggs daily, since some aren't laying yet or have stopped laying. Still, production numbers are impressive, over 500,000 eggs each day. Stack those eggs, and you'd get a column over 29,500 feet tall, 23 times higher than the orbit of the International Space Station. Younger chickens lay eggs almost daily, while older ones do so less frequently. Balanced feed helps boost egg production. Factors like temperature, lighting, and stress-free conditions also play a big role. During winter, shorter daylight hours can slightly reduce laying rates. American eggs are rich in protein, vitamins D and B12, iron, and other nutrients. There are even eggs with higher omega-3 content, depending on the chicken's diet. You know what surprised me the most? The small workforce. Modern automation allows a 1 million chicken farm to operate with just 100 or so workers. Their tasks include equipment monitoring, veterinary care, and managing feed and egg logistics. A farm of this size can generate up to $50 million in annual revenue. This makes a significant contribution to the local economy, especially in logistics, feed production, and processing. These numbers show just how massive and coordinated the effort is to keep a steady flow of eggs heading to stores and ultimately to our kitchens. Have you ever wondered how the beer you drink is made? Imagine this: 1 million tons of grain every year, thousands of bottles filled every minute, and automated machines working with millimeter precision. We are diving into the world of brewing, at the Anheuser-Busch factory, the largest beer producer in the world. We will discover how ordinary barley transforms into a hoppy beverage and why every drop of Budweiser undergoes meticulous quality control. This is not just production. It is a spectacle of scale, flavor, and innovation that you absolutely will not want to miss. Did you know that the average American drinks about 2,500 ounces of beer annually? And while the Czech Republic and Germany lead in beer consumption, Anheuser-Busch supplies a significant portion of the global demand. It all begins with humble barley. At the factory, I witnessed how tons of grain are delivered and processed before being turned into malt, one of beer's main ingredients. Everything here is automated. Specialized machines grind the grain and soak it in water to wake up the enzymes. It literally looks like a dance of machinery, with each piece knowing its role precisely. In enormous steel tanks as tall as a 3-story building, giant machines load tons of golden barley. You can hear the soft, calming sound of the grain cascading downward, reminiscent of gentle rain. What happens next is pure technological magic. Special machines delicately grind the grain, exposing its core, starch. It looks as though the grain passes through a massive waterfall, transforming into a light, fluffy powder. This powder then ends up in enormous vats filled with warm water. Here is an interesting fact. The machines do not simply soak the grain in water. They maintain an ideal temperature and humidity level, like a steam bath designed to activate the enzymes. You can see the vats come alive with hot steam passing through them. Water mixes with the ground grain, forming a thick, creamy mixture that begins to release the aroma of freshly baked bread. This moment feels incredibly vivid. It is as if the grain awakens and starts working together with this mechanical orchestra. The malt vat begins to rotate. Yes, it does not just sit still. It practically dances, with special paddles mixing the blend so the enzymes activate evenly. Steam rises, forming a light mist that fills the room with a sweet aroma. Sometimes this steam is lit with special lamps, adding a touch of spectacle, as if you are witnessing a scene from a sci-fi movie. And this is only the beginning. The porridge then passes through other tanks equipped with precise filters that separate the liquid, the malt extract, from the leftover grain. Now imagine this happening on a scale where a single processing cycle can fill thousands of bottles of beer. This is not just production, it is a full-scale performance. The machines operate with the precision of fine jewelry, and as you stand nearby, you feel like a witness to something monumental. The entire process is filled with rhythm, aromas, and sights that will make you forever respect beer. Though, to be honest, I already respect beer because it sponsors my enjoyable Friday nights. Anheuser-Busch sources barley from various farms, and the quality is scrutinized down to the smallest detail. Different beers require different malts. Lager? A light malt base is needed. Stout? Add darker, roasted malt. You get the idea. They use around 1 million tons of grain annually for beer production. Now for the most exciting part. These giant steel fermentation tanks are so enormous that it feels like you could fit an entire football team inside one. This is where the magic begins. Maltwort, a sweet liquid extracted from the grain, is mixed with hops and yeast. Honestly, the smell in the fermentation hall is something else. It is a warm, rich aroma, reminiscent of bread and fruits. The yeast here works like crazy, turning sugar into alcohol and carbon dioxide. Fermentation lasts anywhere from several days to a few weeks, depending on the type of beer. The factory employs about 4,000 people. It is like a small town. But what surprised me the most is the level of automation. People here mostly monitor the process from screens while the machines handle the bulk of the work. Even the smallest details, like the temperature and pressure inside the tanks, are controlled by computers. Honestly, the factory feels more like a scientific laboratory than a traditional brewery. And it did not start out this technologically advanced. Anheuser-Busch has an incredibly fascinating history. It all began in the year 1852, when a small brewery opened in St. Louis, simply called Bavarian Brewery. In the 1860s, it was purchased by Eberhard Anheuser, a German immigrant, and his son-in-law, Adolphus Busch, joined the business a few years later. That is when the real boom began. Adolphus Busch was not just an entrepreneur, but an innovator. Imagine this. In the year 1876, they created Budweiser, the first American lager beer. To make it accessible anywhere in the United States, Busch introduced revolutionary transportation methods, such as refrigerated railcars. This was a game changer for the beer industry. Today, Anheuser-Busch is part of the AB InBev Corporation, the largest beer producer in the world. Their brands, Budweiser, Michelob, Stella Artois, Corona, are recognized on every continent. According to AB InBev, Budweiser alone is sold in over 85 countries, producing over 2,064 million gallons of beer annually. On average, each production line fills 1,500 bottles or cans per minute. The bottling line is a true showcase of technical perfection. Hundreds of cans and bottles flow in rapid streams, perfectly aligned, gleaming under bright lights. The entire process is fully automated, and watching it is like observing a finely tuned clock mechanism, but on an enormous scale. First, empty bottles or cans enter the conveyor. They are thoroughly washed to remove even the tiniest specks of dust, because cleanliness here is paramount. Machines spin each container under spiral nozzles that shower them with jets of water. Next comes the filling stage. Cans line up under high-precision dispensers that pour the exact amount of beer into each one in mere fractions of a second. Interestingly, this happens in near-vacuum conditions. Why? To prevent foam formation and avoid any contact between the beer and oxygen, as this could affect its flavor. The next step is sealing. Caps for bottles or lids for cans are fed onto the conveyor through a separate line, and special automatic clamps secure them with such speed that it is almost impossible to see the movement with the naked eye. Then comes the packaging. This is where the real conveyor magic happens. Bottles, cans, kegs, everything moves at lightning speed. More than 1,500 bottles are filled and sealed every minute. Watch this rhythm. Every can undergoes a seal test before moving on to packaging. Here is another interesting detail. Bottle coloring and label printing are also automated. Conveyors move, machines blink, and staff only occasionally intervene to ensure everything runs smoothly. Overall, lasers, sensors, and cameras at every stage ensure quality control. If even a single can or bottle fails to meet standards, the machine instantly removes it from the line. This guarantees that only the best product reaches consumers. Despite the scale of production, the taste of the beer remains consistent. That is their top priority. Every batch undergoes tasting before hitting the shelves. And trust me, this is not just a formality. The tasters here work at the level of true sommeliers. And this is just one factory in the Anheuser-Busch network. In total, the company operates 12 breweries in the United States, along with over 20 distribution centers. Another thing that impressed me, Anheuser-Busch actively works to reduce its environmental impact. For instance, the water used in brewing is purified and reused, and all waste, such as grain husks, is sent to farms as livestock feed. You can now tell your spouse, "Honey, I am not just drinking beer, I am supporting cattle feed in the United States. If you survive saying that, let me know how it goes." Although their largest factories are in the United States, the company has facilities on every continent except Antarctica. By the way, the factory in St. Louis is also a tourist attraction. Every year, they host tours for tens of thousands of visitors. Guests are taken to historic production halls, shown giant tanks, and even get to see their famous Clydesdale horses. And if you are wondering whether you can taste the beer, of course. At the end of each tour, guests are invited to a tasting room to sample the freshest beer. Anheuser-Busch is not just a company, it is a living history of innovation, scale, and tradition. They started as a small brewery in St. Louis and have grown into a giant that is reshaping the beer industry. Next time you open a bottle of Budweiser or Michelob, remember these numbers, this scale, and the people behind every drop of beer. Every year, more than 500 billion matches are produced worldwide. That means around 16,000 matches ignite every second. But have you ever wondered how these tiny wooden sticks go through a complex manufacturing process before they end up in your hands? Today, we are diving into the fascinating world of match production. From selecting the right wood to applying the chemical coating that allows them to ignite with a single strike. You will learn how modern factories produce millions of matches daily, what materials they use, and why matches continue to thrive in the market even in the 21st century. The matches we are familiar with first appeared in the 19th century. Let's take a detailed look at each stage of match production. I will tell you all about it, from raw material selection to packaging the final product. The primary material for matchsticks is wood, carefully chosen for its properties. Softwood species are mostly used. Aspen has a uniform structure, is easy to process, does not crack, and provides consistent burning. Poplar is known for being lightweight and widely available. Pine is used less frequently due to its high resin content, but in some regions, it is carefully treated to remove the resin before use. Many manufacturers aim to use waste from the woodworking industry, reducing costs and making production more eco-friendly. The wood is stripped of its bark, sorted, and cut into transportable logs before being sent to the factory. At the factory, the wood is loaded into special drums for cleaning. The logs are then sliced into thin sheets, resembling ribbons. This is done using precision machines with adjustable blades. The ribbons undergo thickness uniformity checks since the quality of the final match depends on it. After slicing the ribbons, they are cut into individual matchsticks. On average, a standard match measures between 1.65 inches and 1.77 inches in length, with a thickness of approximately 0.79 inches. Tell me, did you just measure that too? I do not want to be the only one doing it. The blanks then go through a drying system, reducing their moisture content to an optimal level, no more than 6 or 8%. For additional protection, the blanks are treated with antiseptic solutions to prevent mold, fungi, and insect damage. After this treatment, the matchsticks move to the assembly conveyor. The chemical mixture for match heads is prepared in separate facilities. It is a complex combination of several key components. Oxidizers release oxygen during combustion. Sulfur or other flammable substances ensure stable burning. Phosphorus is the main element that enables instant ignition upon friction. Dyes give the heads their characteristic colors: red, green, black, and more. Adhesives bind the components together. The ingredients are mixed in specialized equipment, and the finished mixture is poured into storage tanks. For worker safety and to prevent spontaneous combustion, all operations take place in explosion-proof rooms with strict temperature control. By the way, did you know that in the year 1826, English pharmacist John Walker invented friction matches? His friction matches consisted of a stick coated with a mixture of antimony sulfide and potassium chlorate. Then, in the 1830s, Frenchman Charles Soria improved them by using red phosphorus, which was less toxic and safer than yellow phosphorus. These matches could ignite only when struck against a specially prepared surface on the box, becoming the prototype of modern safety matches. After applying the chemical mixture, the matchsticks are sent to drying chambers. Here, they undergo a drying process that lasts approximately 2 or 3 hours. These chambers maintain a controlled temperature, ensuring the mixture solidifies evenly. This treatment gives the match heads the necessary strength to prevent crumbling or flaking, even during long-term storage or transportation. This stage is crucial since it forms the core functional part of the match, the head, which ensures its usability and durability. Thanks to modern technology and rigorous quality control, the final product is not only convenient, but also entirely safe for users. While the matches are drying, a separate production line manufactures matchboxes. Cardboard is used, going through several steps, which we will now explore together. Step 1. Cutting sheets into blanks. Step 2. Printing labels, which may include either simple manufacturer information or colorful designs depending on the order. Step 3. Forming the boxes using specialized machines that fold and glue them together. Next, a special abrasive coating is applied to the inner side of the matchbox. This mixture of phosphorus, glue, and quartz sand ensures match ignition. Afterward, the dried matches move onto a conveyor belt, where they are cut to a perfectly uniform length. Then, precision dosing machines distribute the matchsticks into the boxes. Each box is filled with an exact number of matches, usually 40, 50, or 100, depending on the format. Once filled, the boxes are automatically sealed and sent to the packaging line for shipping and storage. The finished match blocks are labeled and sorted onto pallets before being loaded onto trucks for delivery to stores or wholesale suppliers. Now we are in the final stretch of match production, the concluding stage that wraps up this long, intricate, and carefully planned process. At this stage, the finished matchboxes are carefully grouped into bundles, usually containing 10 or 12 boxes. These bundles are tightly wrapped in transparent polyethylene film, which serves several important functions. First, this packaging protects the matches from moisture, preserving their quality during transportation and long-term storage. Second, it makes the products easier to handle and distribute. After packaging, the bundles are labeled according to logistics requirements. Each package includes information about the manufacturer, production date, batch number, and other necessary details. The products are then arranged on pallets, optimizing transportation efficiency. Loaded pallets are transported to trucks, which deliver the finished matches to stores, wholesale warehouses, or even export them abroad. It is important to note that strict quality control is conducted at every stage of the production process. This ensures that the matches meet high standards and satisfy consumer expectations. The wood's uniformity is checked to ensure it is strong, free of cracks and defects, as it forms the foundation of every match. The durability of the match heads is tested to ensure the chemical composition does not crumble or flake, making the matches reliable for use. The ease of ignition against the abrasive surface is controlled, ensuring matches ignite on the first strike while remaining safe for transportation. Match production is a combination of high-tech equipment, natural raw materials, and strict quality control. Each match goes through dozens of steps before reaching store shelves and, ultimately, your hands. Thanks to automation, eco-friendliness, and safe working conditions, the match industry remains an essential part of many economies. Match production is a complex, multi-stage process that integrates modern high-tech equipment, natural raw materials, and strict control at every stage. The process begins with material preparation, including wood and special chemical mixtures for coating match heads, and ends with packaging the final product. Each individual match undergoes dozens of technological operations, including wood processing, chemical application, drying, and quality inspection before reaching store shelves. Automation and eco-friendly technologies ensure that modern match production meets high safety standards for both workers and the environment. Additionally, manufacturers focus on resource conservation and waste minimization, making the process more sustainable. Matches remain an essential part of everyday life for many people, and their production is an important economic sector that supports traditional industries, creates jobs, and generates stable income for many businesses. By combining advanced technology, sustainability, and a commitment to quality and safety, the match industry continues to thrive in the modern world. It might seem that, in the 21st century, lighters should have completely replaced matches, right? But the reality is not that simple. First, matches are an extremely cheap and compact way to start a fire, requiring no additional costs or recharging. They are also highly convenient for short-term use, such as lighting candles, campfires, or outdoor cooking equipment. Another reason is that matches carry a sense of nostalgia and tradition, often associated with a certain aesthetic or atmosphere. In some cases, they are even used in ceremonies, where this small gesture holds symbolic significance. Safety is another factor. Matches do not have mechanical parts or batteries that can fail. For some users, matches provide greater confidence in reliability. So, the next time you strike a match, remember how many people and machines worked to bring it into your hands. And you know what? They did an amazing job. Every single year in the United States, millions of cucumbers are pickled, and it is truly an artistic process. Have you ever stopped to think about how exactly that happens? All those jars of cucumbers lining the supermarket shelves, from the very first to the very last, have been harvested, processed, packed, and delivered, so they can end up right in your hands. So, let us peek behind the scenes together and discover how a full-cycle plant carries out this remarkable process. In the United States, some pickling plants operate their own plantations, where cucumbers are grown specifically for this purpose. It is not just about harvesting, it is also about ensuring that each cucumber has the perfect size and shape. This is no accident. Every cucumber that arrives at the plant must meet strict standards, or the pickling will not be as effective. For example, in the state of Michigan, which is home to one of the largest cucumber pickling companies, the plantation area can span 5,000 or even 10,000 acres. This allows for the cultivation of millions of cucumbers every year. Plants that specialize in pickling handle enormous production volumes. A single plant can process up to 100 million pounds of cucumbers per year. The exact amount depends on the size of the facility and the region. In order to maintain a stable supply to the market, these plantations often have contracts with farmers who grow cucumbers specifically for pickling. Ultimately, from harvest through processing, everything revolves around massive scale. These cucumbers typically measure from about 3 to about 5 inches in length, and their shape must be smooth, without bends or defects. This is important, since crooked or overly large cucumbers will not only look unappealing on store shelves, but can also harm other produce during processing, affecting the overall shelf life. Various technologies are employed on these plantations to ensure uniform cucumber size. For instance, they rely on controlled growing conditions, proper temperature, irrigation, and fertilizers, and row-based planting to avoid excessive competition among the plants. Additionally, automated sorting systems examine each cucumber to confirm it meets the required standards. This makes it possible to remove all imperfect specimens before they ever make it to the pickling stage. Full-cycle pickling plants are not just simple production sites where someone takes a jar and fills it with cucumbers. Rather, they are large-scale complexes in which everything, from gathering the cucumbers, through cleaning them, to packaging and labeling, is done under one roof. Picture vast areas that include not only production lines, but also specialized storage chambers for fresh vegetables, which must remain in pristine condition right up to the moment of pickling. Furthermore, such plants usually have laboratories to monitor product quality at every step. Hence, even when you buy a jar of cucumbers, you can be sure the production process has undergone rigorous scrutiny. As you can see, it is more than just a jar on a shelf. It is the end result of an entire industry that works at every level. The process of harvesting cucumbers on these specialized plantations is quite a spectacle, bringing together manual work and high-level technology. Initially, workers go into the field with baskets or special containers for collecting cucumbers. It is a delicate job because every single cucumber must be plucked by hand so the other plants are not damaged. In the past, harvesting was almost entirely manual. But as technology has advanced, more mechanical methods have been introduced. Nonetheless, workers still check each piece for ripeness and shape. On larger plantations, machines are frequently used to gather cucumbers. These machines feature special drums or vibratory mechanisms designed to collect the cucumbers without harming them. They move along the rows, carefully picking the produce. Although mechanical harvesting is faster, it requires constant supervision to minimize damage. Once harvested, the cucumbers often undergo an initial inspection right in the field. This might include basic sorting by size and shape, filtering out any cucumbers that fail to meet the standards for pickling. Certain plantations use automated systems to do this sorting. Immediately after harvest, cucumbers are transported to the plant for further processing, so their freshness is preserved. All of these steps are carried out very quickly, minimizing the time between picking and processing. Plantations often employ refrigerated trucks to keep the cucumbers from overheating. Now comes the most fascinating part. How exactly do cucumbers land in jars? It begins with washing and sorting. After harvest, cucumbers are thoroughly washed and checked for defects. The washing tanks can hold from about 11 to about 17 short tons of cucumbers at any one time, which is like a whole pool filled with these crispy green fruits. Often, long stainless steel baths are used, where the cucumbers travel along a conveyor belt fully immersed in water. They are first placed in a large water tank for soaking, which loosens soil and leaves. Air bubbles are introduced into the water to gently shake the cucumbers, removing dirt in a way that mimics the gentle motion of a natural stream. This helps avoid mechanical damage. Following the soak, Cucumbers pass under strong shower units that rinse away any remaining residue. The water pressure is high, yet carefully managed so the delicate surface of the cucumbers is not harmed. Afterward, they roll across rows of soft rotating brushes, which remove any fine bits of dirt and give the cucumbers a clean, market-ready appearance. Clean cucumbers undergo a final check. Either cameras or employees examine their condition, looking for any defects, rot, or damage. The water used for washing is circulated through multiple rounds of purification and filtration. Many plants feature systems for reusing water, thereby reducing environmental impact. Only the best cucumbers move on to the next stage: slicing, pickling, and packing into jars. The pickling solution is not merely vinegar mixed with water. It is a carefully formulated combination of various spices, salt, and sugar that yields the cucumber's distinctive taste. Here too, there are secrets. The solution is prepared according to an exact formula specifying the precise amount of each ingredient. Following the washing stage, cucumbers travel by conveyor belt toward the slicing machines. Before slicing, they pass through a laser scanning system that measures their length and shape, ensuring uniform pieces. The slicing itself is performed by rotating stainless steel blades that spin at more than 300 revolutions per minute. The machine can be set for different slicing styles: rounds, strips, or halves, depending on the type of pickles being produced. In 1 minute, a single line can slice and prepare for pickling over 1,100 pounds of cucumbers. The cucumbers then proceed into a large tank, where they are evenly bathed in a hot pickling solution. The makeup of this solution can vary, but it generally includes water, vinegar, salt, sugar, and spices. Special nozzles guarantee thorough distribution of the liquid among all the cucumbers. The cucumbers advance to a specialized conveyor system where robotic manipulators precisely fill each jar. The nozzles measure out the exact amount of pickling solution for every jar. In the final stage, jars pass beneath a presser, which applies lids and hermetically seals them. One production line can handle up to 300 jars per minute. The accuracy of dispensing the pickling solution is calibrated down to the milliliter, ensuring no jar is overfilled. The pickling solution is drawn from dedicated reservoirs through a network of pipes that maintain a constant temperature of around 200 degrees Fahrenheit, thereby sterilizing the jars and prolonging shelf life. Any leftover solution returns to the reservoirs for reuse, which reduces costs. After each recipe change, the equipment automatically undergoes a hot water and steam rinse, ensuring everything remains pristine. Lids come in from a dedicated feeder system, where they are oriented and sent out precisely in sync with the jars on the conveyor. The lids are pressed firmly onto the top of each jar so that an airtight seal is achieved. The lid temperature can be kept at up to about 160 degrees Fahrenheit to aid in forming a secure seal. Sealed jars then move on to a separate conveyor, where labeling is done automatically. 600 labels can be applied per minute. Laser or thermal inkjet printers mark the expiration date and batch number directly on the label or lid. Cameras check label quality, and if any jar has a crooked or missing label, it is automatically diverted for another labeling cycle. In a single 8-hour shift, the plant can seal and label over 192,000 jars. Why are these pickles so delicious and always fresh tasting? Here is the key. Every step, from selection and growing to processing and packaging, is focused on preserving the natural taste of the cucumber while making the product both safe and flavorful for you. Everything is conducted in a manner that ensures efficiency and upholds the strictest quality standards. Thus, in this process, which is driven not only by technological innovation, but also by genuine passion and skill, you can witness true artistry. Each step, from planting the cucumbers to pickling them, deserves special attention. Indeed, even the way the jar looks on the shelf stems from the dedicated work of many individuals who keep refining this process day by day. Every minute, more than 55 short tons of whey protein are produced worldwide. But just a few decades ago, people would simply pour out this liquid, not realizing it held one of the purest sources of protein. Today, it is a multi-billion-dollar industry where ordinary whey from milk undergoes a high-tech journey of filtration, drying, and packaging before ending up in your sports shake. How did this ordinary byproduct of the dairy industry become the foundation of sports nutrition? Let us figure it out. The cycle begins with choosing high-quality raw materials. Do you know what whey is, if we are not talking about vaccines? When milk is used to make cheese or yogurt, it separates into two parts: the solid curd that becomes cheese, and the liquid whey, which was thrown away or used as animal feed several decades ago. However, people discovered that this liquid is full of valuable proteins, so it is now filtered, dried, and transformed into powder. The same whey protein you find on store shelves. When milk curdles, only 10 or 20% of it turns into cheese, while the remaining 80 or 90% is whey. Most large protein producers work directly with farms located near their factories to secure a steady supply of this raw material. In the United States of America and Europe, whey often comes from large dairy farms. In Australia and New Zealand, it is commonly sourced from traditional pasture-based farms, where cows eat natural grass. The quality of the protein depends on the quality of the milk, and that quality is influenced by how cows are raised. This is why some brands emphasize that their whey protein is from grass-fed cows, without antibiotics or hormones, and from certified dairy farms. The type of final product also depends on the milk's fat content. If the milk is used to produce a full-fat cheese, such as cheddar or Gouda, the resulting whey has less fat and is more suitable for making a pure protein powder. If it is a lower-fat cheese or cultured dairy product, the whey may contain more lactose, which affects the flavor and overall quality of the final powder. Many whey protein manufacturers prefer whey from hard cheeses because it typically has a higher concentration of pure protein and fewer byproducts. To make about 2 pounds of cheese, you need approximately 2 1/2 gallons of milk, and the rest of that milk turns into liquid whey, which can be used to obtain protein. Whey protein naturally contains very little fat, since most of the fat stays in the cheese. The whey that will be turned into protein is transported to factories in special sealed containers or tankers. Because whey is a liquid that spoils quickly, it must be delivered at low temperatures to maintain its quality. Once whey is collected from the milk, it is cooled to around 39 degrees Fahrenheit to reduce the risk of bacterial growth. For transport, specialized insulated tankers or trucks with refrigerated compartments are used. These vehicles can maintain a constant temperature to keep the whey fresh during the trip. Transport containers are typically airtight to prevent air from spoiling the whey and to preserve its quality. After delivery, the whey is usually tested to ensure it meets the standards required for further processing into protein. This transport system guarantees that the whey arrives at the factory with its beneficial properties intact and is ready for the next steps of protein powder production. Once the whey reaches the plant, it is carefully transferred from the tankers into large, specialized reservoirs. These are often stainless steel vats or other containers that keep the liquid hygienic. If the whey has not yet been cooled to the ideal temperature, it undergoes additional chilling to prevent bacterial growth and to provide optimal conditions for the next manufacturing stages. At this stage, the whey may pass through filters to remove any foreign particles or unwanted impurities. This step is crucial to avoid quality issues later in the protein production process. Often, the whey is first concentrated by removing some of the water through ultrafiltration or other techniques, which increases the protein content. In certain cases, the whey may be heated to activate specific enzymes or prepare it for subsequent processes, thereby improving the efficiency of protein extraction. Protein, also called a protein molecule, is an organic compound composed of amino acids linked by peptide bonds. It is a major building block of the cells in living organisms and performs numerous vital functions within the body. Proteins play a key role in forming tissues, cells, and organs, as well as in driving various processes essential for an organism's life activities. They are the main components of cells and tissues. Proteins create structures like muscles, skin, hair, nails, organs, and other tissues. Many enzymes are proteins that speed up chemical reactions in the body, including food breakdown, energy production, and other important biochemical functions. Proteins are involved in the transport of molecules and ions in the body, such as hemoglobin, which carries oxygen in the blood. They also regulate various biological processes, including growth and development, and support the body's immune defenses in the form of antibodies. Although supplying energy is not the primary role of protein, the body can use it as an energy source when necessary, especially if carbohydrates and fats are in short supply. Proteins consist of 20 main amino acids, 9 of which are essential, meaning the human body cannot produce them, and they must come from food. Animal products like meat, fish, milk, and eggs contain all the essential amino acids, making them complete protein sources. Membrane filtration is a critical step in processing whey for protein powder production. It allows an efficient separation of the beneficial protein from less useful components, such as lactose, fats, and minerals. This procedure employs special filtration membranes with microscopic pores, functioning like extremely fine sieves that only allow molecules of certain sizes, including proteins, to pass through. 3 main types of membranes are typically used for membrane filtration: ultrafiltration, nanofiltration, and reverse osmosis. In the first stage, membranes with larger pores let water, lactose, and minerals pass through, while holding back larger protein molecules. Nanofiltration membranes have smaller pores, allowing only smaller molecules such as minerals to pass, while retaining bigger protein molecules. The final step, often referred to simply as osmosis in a reverse osmosis system, helps remove water and small molecules like lactose, resulting in a concentrated protein. Once the whey enters the membrane system, it is pushed through the membranes under pressure. The portion of the liquid that contains dissolved substances such as water, lactose, and minerals passes through the membrane, while larger protein molecules remain on the membrane's surface. This approach yields a more concentrated protein. After membrane filtration, the whey is divided into 2 streams. One contains the larger protein molecules, the concentrated protein, which will be further refined into protein powder. The other includes lactose, minerals, and water, and may be discarded or used for other food or industrial purposes. This process can be repeated multiple times to further boost protein concentration, resulting in protein concentrate or protein isolate, which differ in their levels of purity. Following membrane filtration, once the whey has reached a high protein concentration, the next step is drying. This is crucial because it transforms the liquid concentrate into a powdered form that is easy to store, transport, and use. One of the most widespread methods involves exposing the whey concentrate to a stream of heated air, which evaporates the moisture and leaves behind powder. This approach is sometimes referred to as hot air drying, or a form of air-based microfiltration, and it is commonly used to produce powders with a high protein content. In the case of rotary dryers, the whey concentrate is dispensed onto rapidly rotating drums heated by hot air, causing the moisture to evaporate. Another frequently used technique is spray drying, where the whey is sprayed into fine droplets in a chamber that circulates hot air. The droplets quickly lose moisture, forming small particles of powder that readily dissolve in water. During drying, it is crucial to control the temperature, because very high temperatures could damage protein molecules or compromise the final product's quality. Typically, the temperature does not exceed 175 degrees Fahrenheit in order to retain all of the protein's beneficial properties. After this step, the whey becomes a powder with a moisture content of less than 5%. The powder is then stored in sealed packages to prevent it from absorbing moisture from the air. That is all there is to it. The only remaining task is to package the finished protein. Modern factories use high-speed packaging lines. For example, a single automated line can fill up to 40 packages per minute. Over one day, it can pack around 50,000 packages of protein powder, which usually totals 2 or 3 short tons of finished product. The packaging process is completely automated. Powder travels directly from a container or hopper into packaging machines that automatically fill each package with gram-level accuracy, ensuring precise dosing. Packaging machines operate not only at high speed, but also with great precision. They can include sealed closure systems to prevent air and moisture from entering, which helps the product remain fresh. An automated system inspects every package to detect any defects, such as incomplete sealing, and discards flawed packages. Once the protein powder is packed, the packages may be automatically marked, labeled, and moved onto a conveyor for further boxing or palletizing for shipment. These machines are capable of packing up to 1,000 packages per hour into a single box, guaranteeing rapid and efficient delivery of the final product to consumers around the world.